Hi guys, this is another video about control rig, and in this second video I'm gonna start basically on each video I'm gonna start to analyze a little bit the solvers that we can build with control rig. And the first few solvers will be very simple, simply because Unreal provides you with one node that does the solving for you. But I'm gonna try to add a little bit more interesting concepts when we analyze the solver itself. So in the first video we introduced control rig, hoping that I was able to make a good job of translating what a standard workflow in a standard DCC application is into the control rig realm. The amazing solver that we're gonna look at today is the IK solver, and it's specifically it's a 2-bone IK solver, and this is something that Unreal called BasicIK. So the idea, without going into much detail of what an IK is, I assume that you guys are familiar with it, but let's say IK stands for inverse kinematics. The way you manipulate bones or transform in a hierarchy is usually forward kinematics, where you move the parent and the child's move, you move the parent and this child moves. Okay. Inverse kinematics, it's basically the opposite. It's meant to compute and solve, being an IK a solver, and solve the rotation of certain angles based on a transform that happens at the end of the chain rather than at the beginning. So this is my amazing skeletal geometry, and I skinned very poorly this geometry to this bone, so that we only have 3 bones, BasicIK 1, 2, 3, and we have a geometry. That's pretty much it. So I exported this as an FBX. Let's go into data, is this one here, and then I imported the FBX into Unreal. We have this skeletal mesh here, which is exactly the same, and we have the skeleton that's associated with it, and then I've built a control rig. The final result is something that looks amazing, like this one. So you have the child transform. Well, there is a transform at the end of the chain that is defining the rotation of this bone and this bone. And then of course you can move this thing. So usually this is an arm, and this will be the shoulder the shoulder joint, which is usually driven by a clavicle. So you raise your shoulder, the wrist stays still, and then you move the wrist and the shoulder stays still. On top of that, we also in a planar solver like this, the plane that it exists. So in the IK, imagine that between this bone and this bone, there is a 2D plane, like a square. So imagine that you have a square like that. The orientation of that square, which is the solver plane, it's oriented by using something called pole vector, and what you get by that is the twisting around this plane. So what you get is the elbow raising up. So this is what we're going to try to achieve. This is the final result. So the forward solve for this is extremely simple. So I'm going to go through this. Actually, let's start from the setup event. No, actually, let's go to the forward solve, because the setup event is where I'm going to try to implement a little bit more features. So let's assume that your controls are in place. We have 3 controls here. One is the end IK, one is the root IK, and one is the pull vector. The forward solve says, give me the root control IK, and its transformations drive the basic IK01. So this bone here, this one. When it moves, that bone moves. Nothing gets propagated to any children, so this translation only happens on that bone. Then we add the next operation in the event stack is the basic IK, and this is what I was talking about. Like Unreal provides you with a node that is the solver per se, and it takes care of a lot of stuff without you have to do much. So the first thing that we want to plug is something called the effector of the IK, and the effector of the IK is this thing at the very end. Is in Maya is called end effector, and basically this is the transfer that you want to drive the end chain with. So in my case, it's the end IK control. Transfer goes into the effector. The basic IK affects. It only takes 3 joints, and well, 2 bones and the effector item, which are the first bone, the second bone, and the third bone. What I mean by that is that this is basically you need to pass in the chain of these bones. The last thing you want to do is pass in a pull vector, and the translation of the pull vector of this control gets plugged into the pull vector of the node. Now, a couple of things to note here is primary axis and secondary axis and the pull vector kind. So this pull vector, it's basically this plane, it's aiming towards the location of this object. So if I rotate this object, nothing happens. Is the location, is the position in space that defines where this pull vector is and goes. Okay. So I don't remember, but I think the default values for this is direction. Anyway, this needs to be set to location. Then the primary axis is the axis along the chain. And there is a really cool node here that you can use that is called draw hierarchy. Draw hierarchy basically draws the local orient of each hierarchy bone. So everything that is inside here will get this little gizmo. So we can see that the Z axis is up, the Y axis is forward, and the X axis is along the chain. It's like going that way. So this will be the primary axis of the pull vector. This is why you want to have a positive X. So 1, 0, sorry, X1, Y0, Z0. You want this direction here. The secondary axis, it's basically is the axis that aims towards the pull vector. So the pull vector in here being behind the elbow, let's say if this is the elbow of an arm, it's basically pointing the opposite of this axis. So I'm going to take Y, if this is positive Y, I'm going to look at the thing is going the other way, so it's negative Y, and that's why we have negative Y. That's pretty much it. Once you connect these three things together, you get this behavior. Now the standard way, let me unhook completely the setup event. The standard way you would do this is by moving the root IK control. Let me attach this as well. You move this control here, and you would get close to the bone that you want, and you would say set initial transform from closest bone, and you do the same thing here and here again. As I said in the last video, I really don't like this, only because when the hierarchy is more complicated, there might be two joints on top of one another, that they might have different orientation. So at that point, I don't know what I'm swapping to. Can get really confused. So what I really like to do is find a kind of a procedural way to snap these controls in the setup event. So let me put this, well, no, let's keep this detached. So in the setup event, I am taking a node, a bone, and I'm saying snap this bone to the root IK control offset. So this control here is in this world space, but is at 0 in its local space. And remember, these are the values that the animators animate, so it's nice to have them at 0. I'm doing the same thing for the end IK. Now, one difference that you might found is that I really like not to hard code the bones names, because usually if I take this out, if I take these two things out, and this is a preference, and I know very well that the compiler takes care of static values, and I do this mostly for graph readability, but also for easy graph repurposing if I have to do in a different skeleton. So if I take this out and I take the BasicIK bone, get to transform, and the BasicIK3 node, get to transform, and I connect these two together, this is basically the same exact thing. So everything would still be in the right place. Although you can see that here the IK bone, it's in hard-coded within this node, meaning if this was a different skeleton, maybe 3 joints but with different names, I have to go and manually change this in many places. So what I do instead is that I basically promote this to a variable. Actually, I don't know why they didn't enable promote to variable, to be honest, like in a standard blueprint. So I had to manually create a variable here. Not a big deal, to be honest, but just you know, it would be nice to have like in any other blueprint. So let me take these away and let me put these back. So these two nodes are exactly like the nodes I removed. The only difference is that the input name of the bone is a variable. And this variable happens to be start bone name. It happens to be exactly the same name. But if I were to copy this graph into another thing and wanted to have these 3 bones snapped to, let's say, a different naming, I would just have to simply change this name and recompile the graph, and then I would get the things in the right position. That's why I'm doing that. Also, I like to have a variable and read the variable in few places more. Now keep in mind, as I said, they said it in a video and it's written in the docs as well, that all of these are static values. So at the end of the day, if you were to use this thing here, or these two things, there is no, I don't think there is any loss in performance if you're reading this all the time, because when you compile, the graph will take care of understanding what is a static value and optimize it internally. The reason why I'm doing this is for usability and reading better the graph. So I know that here I'm plugging this blue boxes. I can visually see that it's a variable that is plugging in, and if I change the variable, all these things will change automatically. That's pretty much it. There is no other reason. So if you prefer to drag and drop the nodes here, it's perfectly fine. So here I'm saying get me the start bone, which is first bone, the third bone, and then set the control offset. So these two controls now are in place in world space with the offset, and in local space at 0. And then we could have done the same exact thing if I detach this. No, actually not that one. So I can plug that in. We could have done this, get to transform. and potentially add an offset. You can see that now this controller here has been snapped. Oh, not the second one, sorry. This controller here has been snapped to the elbow. And this, if I plug again computation, this does work. Okay. But in order for me to see and the pole vector, I always wanted any rigger in the world will put an offset here. Okay, we could have that offset here in the graph, meaning that once you get the transformation of the bone, move, add the transformation to y, and move y by -5, and there you have it. I prefer though to build the position of the. There is though a better way to position the pole vector in any of your rigs. You can do a little bit of vector math to compute the proper projection of this vector. So if it goes into the right place, where the pole vector will behave properly automatically. This is a habit that comes from Maya, but I still think that placing the pole vector procedurally, it's a good idea, because you always end up having a really nice behavior out of the box. Also, if you compute the position procedurally, you can change completely the orientation of the arm as your input arm, and the pole vector will change place according to the angle of this. So it's really nice to have it procedurally placed. I deleted too many things, I think. Oh no, was this one here? I don't remember. Yeah. Oh, sorry, it's here. Yes. So what I've done here is that I have the position of this pole vector here is actually computed by doing some vector math. I'm not going to go into much detail, but the idea here is that you have a variable that defines the offset, and if I put this variable to 0, the offset goes exactly onto the elbow. This is the variable where I'm scaling a vector. I'm gonna explain it. So let me put this back to 0.5. Well, it was 2, but I want to explain 0.5. The elbow is moving backwards. What is actually happening here, if I put to 1, is that the distance between this joint and this transform is the same distance as if I were to project this transform down to these 2 points. So I'm going to try to make it on a top view. So imagine that you have a line here, and you trace a line from this position to this position, and this plane is not straight. It's not straight. Otherwise, it would have been even more simple. But you cannot assume that your arm is straight or your T pose, whatever. The bind pose is usually an A pose or whatever. So imagine that there is a line from here to here, which is not parallel to the ground, and then a line from here to here. The distance from here to here is the same distance from here to here if you multiply by 1. If you multiply by 2, it's simply double. So now from here to here, it's twice as from here to here. And the way how I computed is as a simple projection of vectors. I'm basically taking the distance. Fortunately, there is not much math involved, because each bone gives you a translation, and the translation is already expressed as a vector. So the only thing I'm doing is calculating it's basically this vector, and this vector. I'm doing a dot product, dividing it, and then basically here is where I'm doing the projection. I'm projecting this thing onto here, and then I am subtracting this and then basically the scale. It's simply you know, it's a multiplication by a scale factor, and that's how I get the position here. So this doing this will give you a really nice procedural way to place the ball vector. This is something that we've been doing in Maya or other packages for a long time. So I'll see if I can try to demonstrate this later. And then what you do is that you connect again the for solve, and that's what you get. The solve per se also includes really cool stuff, and this usually in Maya it becomes complicated to implement. Not complicated, but you know, it complicates the graph visually when you start to implement something like stretching. But here everything it's already exists, so you can have your own variable to drive the amount of stretchiness. You can say I want to stretch this to a maximum of 1, and you know, or a maximum of 3, so it will keep going, and then after a while it stops. Please don't consider the geometry. The geometry is very poorly skinned. What you need to see is the bones where they are stretching to. Yeah, and if I disable the stretch, you can see that the bone stays there. And that's pretty much it. Oh, this is moving because I have both selected, not because there is some kind of weird. I mean, it's not deselecting that. What? Okay. Okay. Let's see. I'm gonna try to do something to justify a bit more of this variable. So let me go into Maya where I have this thing open. Let me move this thing up, rotate it down, rotate this a bit more. Let's make a nice, let's try if this works. And then I'm gonna delete the history on this geometry and skin it again. And the reason why I do that is because so there is a new bind skin, and so when I import this FBX in Unreal, it doesn't do the original bind skin, which is going to use bind pose, which is going to use to define the original position of the skeleton. So this is for Unreal is a brand new skeleton, and this instead I'm going to say arm 01, arm 02, and arm 03. So by all means, this is a completely different skeleton. It's a different naming, and a different orientation. Different. I'm exporting it as an FBX, and we're gonna say import. Now I don't want to use the same skeleton as we had, so I'm going to clear this. So it's brand new basically. I'm trying to. It's brand new. So let me save everything. Let me get rid of that. Let me get rid of the physical asset. I don't need it. So yeah, we only have these two things now. So if I open the skeletal mesh, and it looks like that, and I create a control rig from it. Now we have this hierarchy. Let's say that control rig, if the naming convention is the same on the bones and the proportion are different, you don't have to do any of this. Because control rig already understands that it's the same skeleton just in a different position. So the setup event, if you set it up properly, will snap the controls into the new skeleton position, and that's that, if you do it that way. But I'm trying to build solvers that are a little bit more modular, and so there are certain attributes in the solver that makes the solver a little bit more easy to transfer. If you have to put the setup inside another setup, inside another setup. That's basically the whole goal of having these variables. So the first thing I'm going to do is copy these three controls into the new skeleton. I'm going to create a setup event. Then I am going to take these variables here. 1, 2, 3, 4, compile. Let's put the vector offset to 1. The midnode mode name was, I don't remember anymore, arm02env. arm01, arm03. The variables are initialized correctly. So in theory, if I were to copy this entire graph here, you can see that immediately these controls are in the right place. Now, where is my whole vector control? It's there simply because this is pointing down. I should have thought of that. Hey, maybe what we can do is do this. Get the skin. Reskin it again. Export all. No, different. Here, if we want to reimport the skeletal mesh. Import. And here we want to reimport the hierarchy. Fresh. Different. And you can see that all the controls are in the right place immediately. So it's not much about, and there is not much about transferring this control rig on the same rig, but with different proportion and the same exact skeleton. It's about creating something that you can consider a module, and this module can adapt to a more complicated graph that are one inside another. Now the reason why this is working, of course, is because I haven't copied the forward solve. So copy the forward solve here, and it still doesn't work. And it doesn't work because, well, I have no idea. This should have worked. What's going on here? So the setup event is connected. Solve. Try to see if this is the problem. It is not. Oh, I've made a mistake. But this is, so basically in the original graph, I'm hard coding the bone names. Well, that's unfortunate, but it's easy to fix. Mid needs to go here, end bone needs to go here, start bone needs to go here, and then we take this graph again, and we delete this one, and boom, we copy and paste it. Now it should work. Yes. Sorry about that. I just found a mistake in the previous example. And you see that this is the reason why I like to store things in variable. Again, being them static values, they will not give any problems on having our coded this. It's more to do this kind of stuff instead. That's pretty much it. See you next time.